Question 34 asks, at what location does fx have a relative min? So step 1, we must find the critical point. We must find the first derivative, which is given in the question, and make it into 0. So here we have the equation right there, and we must find the x value to turn that into 0. So we plug in 2. 2 to the power 2 equals 4, so 4 minus 4 equals 0, which works. And on the other hand, we can also use negative 2, because negative 2 to the power 2 also equals 4. So these are our two critical points. Now, what we must do is make an interval line and find points in between these two values. So for example, we are using negative 4, 0, and positive 4. So now we plug in negative 4 back into the derivative of the function and see if we get a positive or negative sign. As you can see, we get a negative value, which means it is decreasing at this interval. Now we plug in 0, and once we do this, we also get a positive function. So positive top, positive bottom equals positive, so it is increasing at this interval. Now for final, we add 4, we put it into the equation, and we get a negative function. So this right here tells us that in between the increase and decrease in value, we get our relative max. And as you can see, that point is 2. So always check between the beginning must be increasing and the ending must be decreasing. So question 35, at what interval is concave up? So again, we must find the critical point of the second derivative and make it equal to 0. So two numbers that make this equal 0 is, as you can see, it's 12 square root and negative 12 square root. As you can see, you plug it in and you both get 0. So these are our two critical points. Again, we make the number line and we find when it concaves down and up. As you can see, we plug in negative 4. Negative 4 to the equation, and that equals a negative. And if it's negative, it means concave down. Again, now we plug in negative 1, and we plug that in, put it into the second derivative, and we get a positive at the top, positive at the bottom. Thus, it's concave up. Now, when we're looking for concave, we always use 0 as an interval. So as you can see, our intervals are negative 4, negative 1, positive 1, and positive 4. So right here, I'm going to skip these two ones to make it faster. So we plug in positive 1 and positive 4. And we also get negative 1 for positive 1. And we get positive for 4. So it concaves down and up there. So now we must find at what point these intervals, or what point, when does this concave up? So as you can see, the two intervals, it concaves up is at negative 12 to 0. And then positive 12 to negative infinity. And that's how you find out. So now we got question 3. So at x equals 0, what is the graph? As you can see right now by looking at the graph, you can tell that it's point of inflection, because that's the middle of the graph and it curves